heavily. So when the p and n regions are heavily doped, this covalent bond disruption takes place there also. But what happens, the only thing is electrons are not able to cross the reverse bias junction in the previous case because of very strong electric field. But if I make my barrier thin and thin, these electrons can easily cross the barrier and give rise to what is called as reverse bias current. So on the minimum voltage, if I'm able to achieve breakdown, then that much heavy amount of current will not flow through my device, leading to permanent breakdown. So what happened? The electron hole pairs got because of this process will increase the reverse bias current, and they will cross the junction, giving rise to reverse bias current. And it happens typically at 6 volt itself for heavily doped PN junction diode. Previously, avalanche breakdown happened at 1000 volt, but this breakdown happened at 6 volt, and the 6 volt we get breakdown because of the heavy doping of P and N regions. So 6 volt you will get a very 6 volt, and with a heavily doped PN junction I'll be getting breakdown, and during that breakdown enormous amount of current is going to flow through my device. So because of heavy doping of P and N region, the depletion region becomes very small, and even when you apply 6 volt or less, the depletion region, the electric field becomes very high across the depletion region, thereby facilitating the charge carriers to cross the depletion region and giving rise to reverse biased current at the breakdown voltage called as Zener breakdown. So the trick is there in doping only. So how much amount of doping I am going to do, that is going to decide my breakdown voltage in Zener diodes. So for lightly doped Zener diodes, the breakdown voltage will be very high, and breakdown is then predominantly happened by avalanche multiplication only. So the purpose of Zener diode itself is the purpose of Zener diode itself is I need to uh, achieve breakdown at a very less voltage. So for that only I'm going to dope the P and N regions heavily. So if the P and N regions are lightly doped, then the breakdown happens at a very high voltage. Maybe instead of happening at 6 volt, it will happen at 30 volt or 40 volt. That becomes conventionally like avalanche breakdown only. So if you want to have a very less breakdown voltage, then you have to go for Zener diode only, which is going to have heavily doped P and N regions. So when you are going to when you want a very high breakdown voltage, then there is no need for Zener diode. You can go for conventional PN junction diode. Or if you dope your PN junction diode very very lightly, then that is not going to anyway contribute to what is called as Zener breakdown. So Zener breakdown, as you hear the name Zener breakdown, two things should be coming to your mind. One is very heavy doping of P and N regions, leading to very minimal depletion region width. And because of this depletion region width, the breakdown happens at very low voltages like 6 volt, which is going to produce enormous current without damaging your diode. Okay, without damaging your